welcome you all. Today we discuss 2.6 article that is about functions of a random variable. Now defined definitions 2.15. So first one is derived random variable. Now each sample value y of a derived random variable y is a mathematical function g of x of a sample value x of another random variable x. So the basic idea here is that if you have a random variable x and you have defined a function that is equal to a new random variable y, so means that x is a independent variable in a function. So that's we call it as a derived random variable. Now let's look at theorem here. Theorem is 2.9. This theorem says that for a discrete random variable x, the PMF of capital Y is equal to g of x is, because as we know that we have to write the PMF for random variable, so it becomes, so this is for random variable y is equal to summation x such that g of x equal to y and px of x. So what we have to do, we just plug in the function values in the PMF of x and we will calculate the PMF for derived random variable. Now let's consider an example how it works. So example is 2.2. So 2.2 a random variable with PMF is given to us, and PMF is px of x 1/4 and x equal to 1, 2, 3 and 4, 0 otherwise. So this is the PMF given to us, and they say that for this sample value, that is the sample value for x, the range is 1, 2, 3 and 4. We define the range for y is equal to function that maps these variables as 10, 19, 27 and 34. Now if I try to look at that, 1 is mapped to 10, similarly 2 is mapped to 19 and so on, 4 is mapped to 34. So now what we have for x we have 4 possibilities with probability 1 by 4 each. Now these are x equal to 1, x equal to 2, x equal to 3 and x equal to 4. Now these are mapped to y as capital Y is equal to 10, capital Y is equal to 19 and capital Y is equal to 27 and capital Y is equal to 34. Now from here we can write the PMF capital Y of y using the theorem. So it becomes 1 by 4 because the probability is the same, but instead of 1 we have y equal to 10. So we write y is equal to 10, then the probability is 1 by 4, instead of 2 we have 19, so it is 19, 27 and 34, and we say otherwise is 0. So this is the way we can use this mapping and to calculate the PMF. Now let's look what about the expected value. So if you remember, if I say what is the expected value of y, so if you remember the formula, expected value is summation belongs to s of y, y, py of y. So in that case 1 by 4 times 10 plus 90 plus 27 and plus 34. So this is the way you can calculate the expected value, and expected value come out to be 22.5. Now let's consider another example. Example is 2.30 to further clarify our concept. So it says that the amplitude of voltage that measures in volts of a sinusoidal signal is a random variable with PMF. So we have a random variable, actually a voltage, it has a sinusoidal signal, and if we look at the PMF, (1 by 7) and 0, -3, -2, 3, 0 otherwise. Now if we try to plot it, so this is a uniform, so if this is -3, -2, -1, 0, 1, 2 and 3. So if the amplitude is 1 by 7 of each. So this is a uniform discrete random variable. Now let define a derived random variable that is equal to y is equal to v squared divided by 2. That is measured in watts. Now denote the average power of the transmission. So this is the average power. Now what we have to do, we have to find PMF y of y. Now we do that. Now so the possible values of y are, how we calculate, we just plug in this formula and we can say that okay, first of all put v is equal to minus 3 here. When we do that, so okay, so we get values. How we do it, just we have how we fill it. For example, we say that okay, y is equal to minus 3. What happened? Then v is equal to minus 3, just y is equal to minus 3 square divided by 2. So it becomes 9 divided by 2. Okay, so this will go for plus as well, because it doesn't matter if you are giving plus into the square or minus. So this is for two values of y. So similarly, when I put y is equal to plus minus 2, y becomes plus minus 2 whole square divided by 2. So it becomes 4 divided by 2. So it becomes 2 here. Similarly, if I put y is equal to plus minus 1, then y becomes plus minus 1 whole square divided by 2. So it becomes 1 by 2. And lastly, y is equal to 0. So this is also 0. Okay. Now there are two outputs here. So what about the probability when y is equal to, so if I have to look at the probability when capital Y is equal to 9 by 2, so this is equal to probability, we have to write from x is for minus 3 plus f(x) of 3. So it becomes 1 by 7 plus 1 by 7. So it becomes 2 by 7. So similarly, for this case, when capital Y is equal to 2, also 2 by 7. Again here probability is for capital Y is equal to 1 by 2 is again 2 by 7, because there are 2 points. So last one is capital Y is equal to 0. It has only one output, that be x of 0, that is equal to 1 by 7. So this means that the possible range becomes 0, and then 1 by 2, then 2, then 9 by 2. So this is possible range. Now if I write PMF, okay, so PMF of y become 1 by 7, 2 by 7 and 0. 1 by 7 when y is equal to 0, 2 by 7 when y is equal to 1 by 2, 2 and 9 by 2, 0 otherwise. So this what we can get. So we can plot these values as well. So this is the way we can calculate the derived random variable. Now let's look at quiz and just clarify this further. Now we have a quiz here. And quiz 2.6 says that monitor had 3 phone calls and observe each one is a voice call or a data call. Okay. The random variable n is the number of so n is actually the number of voice calls. Now question is, assume n has PMF. Okay, we also given PMF for n is that 0.1, 0.30. So 0.1 when n equal to 0, or n equal to 1, 2 and 3, 0 otherwise. So now voice call has cost 25 cents each, and data call cost 40 cents each. Now t cents is the cost of the three telephone calls. Monitor in the experiment. Now question is, one is express t as a function of n. So now question 2 is find pt of t and expected value of t. Now so how we go about it? Now just look at the expression here. So it says that you have 3 phone calls and the possibility of each call is either voice or data, but n is actually number of voice calls. So this means that n gives you information about the voice calls, and t is actually cost, and this is a derived random variable, so we have to write the function t that is a function of n. So this is the thing that we have to do. Now how we do that? We know that this tells us about the voice, and voice is, the value of voice is 25 cents. So this means that we have to multiply 25 times n, that give us the actually voice, because this is for voice this random variable related to the voice call, so plus, but we have to write for data as well, so data cost is 40, okay, from here. Now if there are n voice calls, so the total call is 3, so in that case n can be 0, 1, 2, 3. So we have to put some relation here so that we can get. So this means that if n is 0, then data is 3. If n is 1, then data is 2. So in that case we have to put the total call minus n. So that gives us the data call. So this is the expression that gives us the relation for t. Okay, now we move next. So for first one, capital T is equal to 25n plus 3 minus n times 40. So this is equation that we get. Now we have to look at for second one, we have to calculate PMF for T and also. So before that, so it's better to write the range of S of n. So if I write the range, this becomes, we have 0, we have 1, we have 2, and we have 3. So this is the range for S of n. Now to calculate the range for S of t, so we have to write S of t here. Now we use this formulation. When we put 0 here, so it becomes 0, this becomes 3 times 40, and so if you do that, so it's better to write here. We say that when n is equal to 0, then t is equal to 25 times 0 plus 3 minus 0 times 40. So it becomes 120. Similarly, when n is equal to 1, t becomes 25 into 1 plus 3 minus 1 times 40. So when we do that, this becomes 25 and plus this becomes 80, so it becomes 105. When we say n is equal to 2, t becomes 25 into 2 plus 3 minus 2 times 40, so it becomes 50 plus 40, it becomes 90. N is equal to 3, so in that case 25 into 3 plus 3 minus 3 times 40, so it becomes 75. Okay, so this is the range, so means that we have the values. Of course for 0 is 120, but if we write in form, that is 75, 90, 105 and 120. So when we do that, we complete the one off. Now second thing is we have to look for the probabilities. So for that case, we know that we have to find the probability when capital T is equal to 75. This is equal to probability when capital N is equal to 3. So we have to look at the available relation, and that tell us that this is equal to 0.3. Similarly, when probability capital T is equal to 90, in that case probability of capital N is equal to, sorry, let me rewrite here. I can write in PMF, so N2 is again 0.3. Similarly, probability when capital T is equal to 105, it is also 0.3. Now last one, probability when capital T is equal to 120. So in that case, Pn of 0, that is equal to 0.1. So when we do that, now it's very easy to write the PMF for T. Okay, so T of T is equal to we have 0.1 when n is equal to 0, and we have 0.3 when n not 0, n is 120. Okay, so let me rewrite here, sorry about that. N is 120, and not n, it's T. What I'm doing here, a bit confused between T and, so this is for T, so you have to put T equal to 0. Okay, so similarly when T is equal to 75, T is equal to 90, T is equal to 105, so you have this value. 0 is otherwise. So this is the way you can easily write the PMF. Now next question is to calculate the expected value of T. The expected value of T is summation T belongs to range of T and T times PT of T. So this is the, so what we have to do, we have to just write 0.1 times 120 plus 0.3 times 75 plus 90 plus 105. When we solve this, it becomes expected value of T that come out to be so if I multiply by this, this becomes 12 plus, if I add this, and it becomes let me do this manipulation, 75 plus 90 plus 105, so it becomes 270. We have to multiply 0.3, it becomes 81. So 81, so 81 plus 12, it becomes 93. So this is what you get when you are solving this derived random variable. So this is the way you can solve these expressions. Now we will move to next article. It's 2.7, and this is expected value of a derived random variable. Now in this article, so we start with the theorem. Theorem is 2.10. so this says that given a random variable x with PMF x and the derived random variable, say y, okay, that is equal to g of x, the expected value of y is, so we can write expected value of y is equal to mu of y, and we have to look for this relation that x belongs to s of y, s of x, okay. So we can directly write it from the relation, but what we know, we must know the transformation times probability PMF of x. So we can use the PMF of the independent random variable and the function, multiply with the function, we get the same result. Now let's look at quickly an example to understand this idea. Example says that PMF given to us is 1 by 4. This is continuation of the previous example, that is 1, 2 and 3 and 4, and 0 otherwise. Okay, and y is equal to g of x is also given to us, and that is equal to 10.5x minus 0.5x square, and this is when x is between 1 and 5. So this is the function, okay, definition, and 50 when x is between 6 and 10. Now question is what is expected value of y? Now we use this theorem to find it, and we say that okay, expected value of y is equal to summation x belongs to s of x g of x times p x of x. Okay, now for that case we have 1, 2, 3, 4 values, so we can write it g of 1 times p x of 1 plus g of 2 times p x of 2 plus g3 times px of 3 and plus g4 times px of 4. So this is the solution. Now just put in the value when g of 1, so for 1 we have to put this relation, so we have to put 1 here, okay, and then 1 also here, so when we solve it, it becomes 10 actually. Px of 1 is 4, so 10 times 1 by 4 plus when we put 2 here, it becomes 19, so this becomes 19 times 1 by 4 here plus when we put 3 here, so 3 becomes 27 times 1 by 4 plus when I put 4 here, 4 will also fall in this range. When I did that, it becomes 34 times 1 by 4. When I solve this, easily I get the same result which I get in previous example. So this is same result with the previous formula. So 22.5 is the answer. So this help us to easily calculate the expected value without calculating the PMF for y, or derived random variable. Now let's go to next theorem, is 2.11, and it says that for any random variable x, expected value, if you want to calculate x minus and minus the from the variable minus the expected value, this is equal to 0. So this is a very important theorem. Next theorem is theorem 2.12, that says that for any random variable x, expected value of a scalar multiplied by a random variable plus a scalar is equal to scalar times the expected value of x plus that scalar. So this means that expected value follows the linearization or superposition. Now let's look at example here. So example is 2.33, and example says that 2.32, it says that PMF is given to us, PR of R, that is 1 by 4, 3 by 4 and 0. 1 by 4 when R equal to 0, R equal to 2 is 3 by 4 and 0 otherwise. Now he is asking that and he says that expected value of R is also given to us, that is equal to 3 by 2. Now he says what is the expected value. You want us to calculate the expected value of V when V is equal to G of R. That follows a relation that is 4R plus 7. So if we apply the theorem 12 to do that, we can say that expected value of V can be written as expected value of 4R plus 7. Now we apply the theorem 2.12, it becomes 4 times expected value of R plus 7. So as we know that expected value of R is 3 by 2, so it becomes 4 times 3 by 2 plus 7. Now if we solve it, it becomes 13. Okay. So this is the way you can easily solve the problem applying the theorem. Now let's consider another example here. Example is 2.33, and it says that if W is equal to H of R and R is equal to R square, so what is expected value of W? So now they are continuation of the previous example. Now if you remember, in previous example we have PR of R that is given to us as 1 by 4, 3 by 4 and 0 otherwise, R equal to 2, R equal to 0. Okay. Now and we also know that expected value of R is equal to 3 by 2. Now question is that can we solve it directly? So if we apply the theorem 2.10, so theorem 2.10 says that expected value of W is equal to summation function, if you remember, that is HR times PMF of R of R. So we apply this theorem instead of directly apply the formula. Why? I told you. When H of R, so H of R is this, when R is 0, so this is equal to H of 0 times PR of 0 plus H of 2 times PR of 2. Otherwise the value is 0, so there is no need of writing those values. So expected value of W becomes H of 0 is 0. When I multiply with 0, because when I put 0 here it becomes 0, so it becomes 0 times 1 by 4 plus when I put 2 here it becomes 4 times the PR of 2 is 3 by 4. So result is 3. Now if I apply the let's apply theorem 2.12. So this is important to note. When we do that, theorem expected value of can be equal to expected value of R square. So as you know, expected R is 2 by 2 square, so it becomes 9 by 4, which is not equal to expected value of W. So the important point here is that this theorem expected values work only for linear combination. Okay, so you can not apply theorem 2 here. This is wrong. Okay, you have to apply theorem 12 when you have a linear relation, otherwise you can't. Now let's move to quiz here. Quiz 2.7, and quiz says that the number of memory chip M needed to in a personal computer depend on how many application programs A the owner want to run simultaneously. Okay, the number of chips and the number of application program A are described. So we have number of chips that is described by M, that tells us the number of chips. For example, we have 4 chips for one program. Again we have 4 chips for 2 programs. We have 6 chips for 3 programs, and we again have 8 chips for 4 programs. So this is the number of chips, and we have relation, we have PMF given to us for a program is equal to 0.1 times 5 minus a when you have a program 1, 2, 3 and 4, and otherwise is 0. So this is the probability PMF given to us. Okay. Now question is first one, what is the expected value? What is the expected number of programs, that is mu of A, that is equal to expected value of A? So first is this question. So to answer this, just apply the formula. So expected value of A, that is equal to mu of A, that is equal to, just multiply, just apply the formula. That means that you have A times P A of A. A belongs to S of A. Now from here this becomes okay, A is 1 time, just plug in 1 here, it becomes 0.4. Okay, then if you put the 2 here 2 times, it becomes 0.3, plus when you put 3 here it becomes 2, so 3 multiplied by 0.2. Similarly, when you put 4, it becomes 4 multiplied by 0.1. So when you solve it, expected value come out to be 2. Now the next question, question number 2 is express M equal to G of A. Now number of programs. So G of A, and so we can say that okay, we have to use this information, and we say that okay, capital M is equal to, look here, for 4s we have 2A, so this means that this is 4 when value of A is equal to 1 and 2. Then 6 when values of A is equal to 3, put small a, it's better. Similarly it is 8 when a equal to 4. This is the relation that maps m into a. So we can, let me rewrite here, we can say that this is g of a, this is equal to n. So this is the information I just wrote here. Now third question is, for this quiz, is find expected value of m does the expected value of m is equal to, okay, now expected value of m is equal to expected value of g of a, and then he says, does expected value of m is equal to g of expected value of a. So this is the question that we have to answer. Now expected value of m, so expected value of m is actually, we have to use is from 1 to 4 g of a times p a of a. Okay. So this theorem helps us to answer this question. Now when we put g of a is equal to 1, so this means that this is g of 1 p a of 1 plus, we say that g of 2 p a of 2, okay, plus g of 3 p a of 3, and plus g of 4 p a of 4. Now when we put the value g1 of 1, so this becomes 4, because g1 of 1 is 4, so we have to put 4 multiplied by p1 of a, so we have to put values here. This becomes 0.4 plus g2 of again 4 times, this is 0.3 plus g3, if you put, this is also 3 is 6, so 6 times 0.2, and lastly g3 is g4 is 8, so we say that this is 8 times 0.1. When we solve it, the result becomes 4.8. Now the next he's asking to calculate expected value of g of a. Okay. No, sorry, we calculate expected value of m. Now he's asking about this thing. Now for that reason, as we know that expected value of a is 2, now he said expected value of m, that is equal to g of expected value of a, that is equal to g of, what is expected value of a? So expected value of a we already calculated, that is 2 here. This is g of 2. Now expected value of m, that is equal to g of 2. Now g of 2 is actually, when we look at the relation, 2 is 4. It's 4. So this means that it's not equal to the expected value, that is 4.8. Okay. Now this relation is not true, so this means that you can't replace the function out from the expected value. Okay, So this is also not a linear relation. Now I will stop here. We'll continue further in next lecture. Thank you.